Hello everyone. Today we'll be analyzing two graphs. One is an example of a well-designed data visualization, while the other highlights some common pitfalls in data presentation. We'll examine each graph in terms of its purpose, variables, design choices, and effectiveness. Let's start with a graph of perceptions of probability first, which we consider a strong example of effective data visualization. This graph is titled Perceptions of Probability. The author here is trying to capture how people interpret probability phrases like almost certainly or unlikely and the numerical probabilities they assign to these phrases. In terms of variables, we have phrase, which is nominal on the y-axis, and a sign probability, which is continuous on the x-axis. Each phrase represents a subjective way of expressing probability, and the x-axis shows the range of numerical values that people associate with each phrase. The author uses color to differentiate each probability phrase and the box plots to show the distribution of assigned probabilities. Each dot represents an individual data point, providing a detailed look at variability in interpretation. This allows us to see not only the average interpretation of each phrase, but also the range of responses. This graph is highly effective because it provides clear insights into both central tendency and variation of each phrase. It's visually engaging with a clean, organized layout that makes comparisons easy. The use of box plots is appropriate for showing how people's interpretations vary. Overall, this graph successfully communicates its message, illustrating the subjective nature of probability language and how different terms cluster around certain probability ranges. Now let's move on to the second graph, which tries to visualize diabetes prevalence by race and ethnicity. The author's intent here is to show disparities in diabetes across different racial and ethnic groups in the United States. However, as we'll see, several design issues limit the effectiveness of this graph. The variables here are race ethnicity, which is nominal, and diabetes prevalence percentage, which is continuous. There are no traditional x and y axes in this graph. Instead, each group has a bar representing its diabetes prevalence percentage. The author uses color inconsistently, which doesn't add meaningful information and may even confuse viewers. Additionally, the stylized illustrations of people below serve no purpose related to the data and create unnecessary visual noise. This graph has several issues. First, inconsistent colors. The random use of colors for each bar makes it difficult to interpret or identify patterns quickly. Second, no sorting by prevalence. The groups aren't ordered by prevalence, which would have made it easier to compare values. Third, visual clutter from illustrations. The cartoon-like figures add no data value and distract from the graph's main message. Fourth, lack of context. There's no information about sample size or data sources, which could lead to questions about the reliability of the data. These issues make the graph less effective at conveying information and detract from purpose of highlighting diabetes disparities. To improve the graph, we suggest sorting the bars in descending order by prevalence for easier comparison. Using a consistent color scheme or gradient to represent increasing prevalence, or removing unnecessary illustrations to reduce clutter. We could also add context about the data source or sample size to build credibility. These changes would make the graph clearer and help it better communicate the intended message. In summary, our first graph effectively uses color, layout, and appropriate design elements to clearly convey information about subjective probability. The second graph, on the other hand, could benefit from a more thoughtful approach to color, layout, and context to avoid visual clutter and improve interpretability. These are the references. Thank you for watching.